Have you ever stopped to think about how a company goes from just a few people in a single room to a massive global enterprise? Well, it's not some kind of magic. It's all about a stack of really clever networking technologies. And today, we're going to break down exactly how they pull it off.
So here's the big question we're tackling. How does a tiny startup, maybe sharing one little internet connection, make that leap to become a secure worldwide company? We're going to follow the story of a fictional company to see the three key pieces of tech that make this incredible growth happen.
All right, let's kick things off at square one, a startup's network journey. We'll start with our company's humble beginnings, because that's where we run into the very first networking problem that every single growing business has to solve.
So meet span engineering. Picture this. In the early days, it's just a handful of employees, all crammed into one office. They've got a simple local area network, a LAN, hooking up their computers and printers, and they've got one single connection to the internet. It's simple. It works. But the second they connected to the outside world, they slammed right into their first major networking hurdle.
And that first big hurdle?
Yeah, it's all about addresses. You see, the internet started running out of public IP addresses almost as soon as it got popular. So a small company like Span Engineering, with its 5 computers, a printer, and a server, had no way of getting a unique public address for every single one of its devices.
The solution really comes down to understanding these two types of addresses. Inside their office, on their private network, they can use as many private IP addresses as they want. Think of these like internal office phone extensions. But to talk to the rest of the world, the internet, they need a public IP address. That's like the building's main single phone number. So you see the problem, right? They only have one public number, but a whole bunch of devices that all need to make calls.
And this analogy just illustrates the solution so perfectly. It's a technology called Network Address Translation, or NAT. Imagine your whole company has just one public street address. The receptionist is the NAT device. They take all the outgoing mail from hundreds of different desks, slap the company's single public address on it, and send it out. Then, when mail comes back to that one address, the receptionist knows exactly which internal office and desk it's meant for. It's brilliant.
So, let's look at how that receptionist process works in the digital world. First, your PC sends a request to the internet using its private address. The router, acting as our receptionist, grabs it. It makes a little note in its table, mapping your private address to the company's one public address. Then, it sends your data out. When the response comes back from the internet, the router just checks its table, sees who the response is for, and sends it right back to your computer. It's a totally seamless translation.
Now, NAT comes in a few different flavors, but the real star of the show, the one that makes the modern internet possible, is on the right. Port Address Translation, or PAT. This is the absolute magic that lets hundreds or even thousands of devices inside a network share a single public IP address. It just uses a different port number to keep track of every conversation. This is almost definitely what your router at home is doing this very second.
Okay, so with that address problem totally solved by NAT, Span Engineering is doing great. In fact, they're doing so great that it's time to expand. And this brings us to our next chapter, connecting a growing company. Because, as you're about to see, when you expand physically, you get a whole new set of networking challenges. Business is booming. SPAN opens up new offices in different cities. This is fantastic news, but it creates a whole new headache. They now have multiple, completely separate local area networks that have no idea how to talk to each other. So how do you get the network in New York to work seamlessly with the one in San Francisco?
The answer really gets to the heart of the difference between a LAN and a WAN. Your LAN, your local area network, is what you have in your office. You own it, you control it, it's super fast, but it's small. A wide area network, a WAN, is what you use to connect all those separate LANs together over huge distances. The key thing is, you don't own the WAN. You're basically leasing access to it from a big service provider.
So let's just quickly trace SPAN's evolution. Stage 1. Remember this? The small network. Just one office, one LAN, a basic internet connection. Simple and easy.
Then they hit stage 2. As they grew to fill an entire building, they built a campus network. Still just one physical location, but now with multiple LANs, all connected, their own IT staff, and some serious security hardware.
And that brings us to stage 3, the distributed network. Now they've got offices in totally different cities, and they have to connect them. They do this by leasing private lines from a service provider to create their own private wide area network. This is the critical moment. This is what turns them from just a local business into a truly connected multi-site company.
But all this growth, all this sensitive company data now flying between cities over networks they don't even own, well, that creates our third and maybe most critical challenge. This brings us to our next section, building a digital fortress. How on earth do you keep all that data safe from prying eyes?
I love this analogy. Sending your company's private financial data or secret project plans over the public internet is literally like sending a postcard. Anybody along the way, the mail carrier, the person at the sorting facility, they can all just pick it up and read exactly what it says. It is completely out in the open.
So what's the fix? A virtual private network, or VPN. A VPN takes that exposed postcard, shoves it inside a locked, armored briefcase, and then sends it. Nobody can see what's inside except for the person on the other end who has the one and only key. It's like building your own secure, private tunnel right through the middle of the public internet.
And for a company like Span, they use this in two main ways. On the left, a site-to-site VPN. Think of this as a permanent, secure bridge that's always connecting two of their office networks. It's just on, all the time. Employees don't even know it's there. On the right, a remote access VPN. This is for a single person, maybe an employee working from home or at a coffee shop. They have to actively connect to the network to get that secure access, like they're dialing in to the office.
So what's the tech behind the scenes making this also secure? It's a framework called IPsec, and it basically makes three core promises. First is confidentiality, which means everything is encrypted so no one can read it. Second is integrity, which guarantees that the data wasn't secretly changed along the way. And third is authentication, which proves you're actually talking to the real Span engineering network and not some imposter.
So, when you put all of these amazing pieces together, the NAT, the WANs, and the VPNs, we finally arrive at our destination, our modern connected world. Span Engineering has officially completed its transformation from a tiny office into a global powerhouse.
Just look at them now. From that one little office, they are now a global, interconnected, and most importantly, secure enterprise. Every single employee, it doesn't matter if they're at headquarters, a branch office, or working from their kitchen table, can get the resources they need safely and efficiently.
So let's just boil it all down one last time. It really comes down to three problems and three elegant solutions. NAT solved the address shortage problem. WANs solved the distance problem. And VPNs solved the security problem. It's that simple, each one tackling a different, crucial challenge on the road to growth. And that really leaves us with one final big question. We have built these incredibly complex networks that connect our entire world. But as they get even bigger and even more woven into every part of our lives, the challenge of securing them just keeps growing. So what do you think the next frontier is? What's the next great hurdle we'll have to overcome to protect our digital world?